Welcome. In this module, we will continue to discuss NoSQL databases. We'll do a quick review of the types of NoSQL databases. So we have looked at the key value store, columnar database and graph database in the earlier video. So in this video, we are going to see the evolution of the document database. So before we look into that, it's important to see how the document database evolved. So we are going to look at object-oriented databases and then XML databases and finally the document databases. Alright, so let's get started. Let's review the 4 types of NoSQL database. One is the key value store. So as we have seen, it stores the simplest data model of key and the corresponding value. Then the columnar database like the Cassandra database, Apache Cassandra, so which stores data in columnar forms, in column families rather than rows that are usually done by your relational database. Then the graph database, which emphasizes the relationship between the entities more than the entities itself, right? So it helps to intuitively store data in a connected world. So the final database is a document database. So this module, we are going to take a deep dive into the document database and understand some of its flavors like your MongoDB, Couchbase, etc. So coming back to the NoSQL database, it's important to understand the object relational impedance mismatch that we already talked about, right? So there is this mismatch that exists between the physical data model and the objects in an application code, which is usually written in an object-oriented programming language. So there is a need for this translation layer, and NoSQL database, because of their need, because of their schema-less data models, they tend to make this translation easier, right? By storing the data in the same format as being used by your application. So this will sort of give you the understanding to see the evolution of document databases. So as the very first database, let's look at object-oriented database, right? So your object-oriented database is essentially a database system that can work with complex data objects that mirror those used in your object-oriented programming language, right? So here you have, so previously you had relational database systems, right? Where each of the entities has to be saved as the table. Here, whereas your application is essentially using your object-oriented way of programming. So the object-oriented database OOD helps to mirror objects that are being used in your application. So OODs are often used with the equivalent object-oriented languages such as Java, Node.js, Swift, etc., right, in the application layer of the code. So the object-oriented database system stores and manages objects directly on the database. So there are no tables or rows and columns, only objects, right? So it directly stores the object in the physical database, which corresponds to the objects in your application layer as well. So of course, there is backward compatibility. So relational database, because of the emergence of object-oriented database, we found that relational database also supports object-like data types, right? Your JSON, your XML kind of data types. So in a person's table, you can actually store some of the information about the person in JSON format. So there are multiple flavors of object-oriented database. One is the ObjectDB, which works with Java. Then you have the Gemstone realm, which is mainly used for mobile programming. So it's important to understand again the pros and cons of object-oriented database. Some of the advantage is it helps to store complex data, right, and wider variety of data types into your physical store as well. Easy to save and retrieve data quickly because it's in exactly the same format as what the application needs, right? So there is no translation that essentially happen. Seamless integration with object-oriented programming language. So if your application is using an object-oriented programming language, it becomes seamlessly integrated. Easier to model advanced real-world problems, right? Because real-world looks at data, looks at information in object form. So your physical model is also models the real world object itself. Extensible with custom data types like your JSON, XML, etc. Right? Of course, there are some disadvantages as well. It is not as widely adopted as RDBMS, right? Because as we have seen, relational database, because it's been there for a long time, it is also great in its popularity. The query syntax is language dependent instead of standard SQL, right? So your SQL, irrespective of whichever RDBMS you're using, you can retrieve data, right? Whereas in an object-oriented database, your query language is language dependent. So there are views in a database which don't get supported in your object-oriented. So you can combine different tables to create temporary views, right? They are not supported in your object-oriented database. It does have high complexity, sometimes causes performance issues. The security mechanism and access rights to object do not exist. Whereas in relational database, you do have access data to accessibility of different levels of access to the users of your database. So from your object-oriented database came another version of it called the XML database. So let's take a look at that. So our XML database stands for your extensible markup language. That's what XML stands for, and data is hierarchical in nature. So XML database and .xml files are synonymously used, right? So XML database refers to your .xml file, which essentially is an extension of your HTML data. In your XML, you don't have tags like your hypertext markup language. You have extensible markup language, and data is stored in a hierarchical manner. An XML database is a data persistent software system that is used for storing huge amount of information in XML format. So as I said, it's not, the file is considered a database by itself, right? So you are essentially storing a huge amount of information in XML format. XML database is used quite a lot for communication between software systems. So any sort of interfacing between two software systems, right? In the 90s, they used to be done using the XML format. So data is extracted from a database and put into XML documents and vice versa. And some content-based application also stores data as XML documents so that it's easy to read. Considered to be a flavor of a document database. So let's take a look at an example of an XML database. So you can see that here a table named contact info is created and holds multiple contacts, contact 1, contact 2, etc. And each one contains 3 entities. Your contact has name, company, and phone. Alright, so here you can see it's hierarchical. So you have your contact info is the table, then you have contacts, right? And each contact has multiple attributes. So this is an example of an XML file, a typical XML file. It is all, that XML file is essentially what we call a XML DB. Okay, so there are two formats of XML database. One is called XML enabled database, right? So XML enabled database is essentially because of the popularity of XML, right? Relational databases also started supporting XML data type, right? So an XML enabled database is that offers one or more approaches to store XML within the traditional relational structure, right? So there was XML data type. You can create columns with XML data type, right? So one such example is you can represent your XML as a character large object club, or as native XML type defined by the ISO standard, and XML shredded into a series of table based on the schema, right? So that is another way in which you can have database that supports XML format. So RDBMS that support XML type are your IBM DB2, your Microsoft SQL Server, Oracle Postgres. They all have XML data type, right? Other than the XML enabled database, there is also native XML databases, which are essentially XML files, right? So you can either store your data as XML files or put any XML information in if you want to use it along with relational database, right? Or so you can use it in XML enabled database. So your native XML database is your XML file, especially tailored for working with XML data. So they are optimized data structure used for storage and querying, right? So as we have seen, we'll talk a little bit about querying in the subsequent slide. So you can essentially use your XML format to interface between two databases and also to store some information. Any application can also store information in XML format. So your XML nodes and documents are the fundamental unit of logical storage, and data is queried using XQuery that includes XPath expression as the sublanguage. So to query your XML database also, there is SQL-like flower, right? It stands for let, where, order by, return expression. It has SQL-like expressions to query your XML file. So how do we go about querying an XML file? So let's take an example of your XML file. So in this XML file, you see it's a bookstore XML file. Then you have, book, under that the book, and each of the categories of the book, and the title, the author, the year, and the price of a book, right? So here an XPath expression is typically a way that is used to query your XML file. So you can look at your document, which is books.xml, and traverse the hierarchical fashion, right? Your bookstore book, and you're looking for a book where price is greater than 30 and the title of such a book. Whereas you can also do XQuery, right? So for XQuery, you are using the flower expression, right? You are using for, selects the sequence of nodes, right? Of course, we are not using let here, where the condition we are writing. So it's, you can see that it resembles a SQL query, right? So where, and then here we are not doing order by, and returning which attribute you want, right? So at the end of the day, the output that you are going to get from both of it is the XQuery kickstart and learning XML, because, so if you look at your XQuery kickstart, learning XML, the price is greater than 30. Whereas your Harry Potter and your everyday Italian, the price is 30 or 29.99, right? So this is typically how you would query your XML database. So now let's take a look at the difference between, there are two very popular database data formats. One is called the JSON, the other is XML, right? So we've taken a look at XML, right? So JSON is also a data interchange format. So both JSON and XML are data interchange formats that are used between software systems. JSON stands for JavaScript Object Notation. Is a format for data exchange and only provides a data encoding specification. So it's more popular as it's a native format for data in JavaScript application, whereas your XML is a language, right? So JSON is a format, whereas XML is a language. It's considered a language. It stands for Extensible Markup Language. The language to specify custom markup languages and provide lot more than data exchange, right? You are not only using it for data exchange, you are essentially helping to store information as well in XML format, whereas JSON is more for data exchange, right? XML language has strict semantics, strict rules, right? So the XML defined a standard to assert data integrity for XML documents. So the format should be in a hierarchical fashion. So your document needs to be written in a certain format. So it's typically used in application with complex requirements surrounding data interchange. Whereas your JSON is typically it's fairly simple and straightforward. Okay. So this is all of this is important because this acts as a precursor to understand document database. So your object-oriented database and your XML database essentially created the way for document-oriented database. So now let's look at that. A document-oriented database is a data storage designed for storing, retrieving, managing semi-structured data, which are also called documents, right? So your document is typically a document which could, so now you can sort of start seeing this relationship, right? Your document can be in XML format, your document can be in JSON format. So based on the concept of document as self-contained data entry containing everything needed to understand its meanings, like documents in real life, right? So it's based on so you are storing the document as such, which is encompassing all the related information along with it, right? A document encapsulates and encodes data in standard formats. So typical document-oriented database stores document in XML, YAML, your JSON, BSON formats, etc. All information for a given object is stored in a single instance of the database, and each stored object can be different from each other. So let's take a look at the example here, right? So here you have, let's say you're storing your user information. So you have Brendan and Sean, right? So Brendan first name, last name is there. Whereas for Sean Johnson, we also have the Twitter handle, right? So you see that each is a JSON format, but because it is semi-structured data, right? So there could be for different objects, there could be slightly different set of attributes, right? So each object can be different from each other, right? So all information, so let's repeat this. All information for a given object is stored in a single instance of the database, right? So all information about the user is stored in this single document, right? And each object is different from each other. So depending on what information we have about each user, so these two are different, right? So one of the key important advantages of your document oriented database is it eliminates the need for this object relational mapping. So you can typically store your data in your database in the same format as what is required by your object, right? So then it results in faster software development. So let's quickly Having seen the document database, let's look at the pros and cons of the document database. So one of the key advantages of your document database results in rapid development cycle, as application logic is easier to write due to flexible data models, right? So you don't necessarily have to do this translation layer, resulting in the object relational impedance mismatch, right? So that is why you will see a lot of applications sort of adopted document databases, because it results in rapid development cycles, because you can just store data in the document database, and each document need not have the exact strict variations, so each of it can have different set of attributes. So it's very fast compared to your RDBMS. It is schema free, right? It's distributed and it runs very well on cloud and easy to scale, right? So as the, let's say you are a lot of information such as your user profile information, or the application information, or the loading of your front end with a lot of information like your in your e-commerce website, etc. A lot of it has become document databases. Of course, there are disadvantages as well. Document database is not suited for interconnected data and does not support join. Of course, you can see that some of the later versions of document database, MongoDB, do support some kind of join, right? But the traditional version does not support join. Of course, document database, the technology is still maturing. So one of the key problems about the technology being still maturing is the consistency check, right? So we will sort of talk about in the subsequent module some of the inherent property of your RDBMS, your asset property, which may not be the case for document database. So in a document database, there is consistency check limitation, which means each object can have multiple duplicated information. So there is no strict check on data consistency. So you can start seeing that when we talked about relational database, we talked about normalizing your data, right? You don't want to have duplicate copies of your data. But most of the NoSQL databases tend to be denormalized because there is no clear checks in place. So before we end, I wanted to talk a little bit about comparing how do we mentally map this document database. So we've sort of seen the evolution of document database, right? From your object-oriented database, then your XML, and then you have your document database. So if you compare it with relational database, document database data formats are not predefined in a document database, right? So you can have semi-structured data, which in JSON format, your XML format, etc. Whereas in a relational database, you need to have data in a specific format. So if you compare it with key value store, so is there a way to understand document database from key value store? Yes, you can think of your document database as a specialized key value store where the document content is not opaque, right? And there are APIs that expose the ability to query and update based on the internal structure of the document. So if you look at the JSON itself contains a lot of sort of key value pair, right? So it's a specialized key value store where the document is not opaque. You're not querying the entire document, but you can sort of think of it as a key value store querying the internal structure of the document. So if you compare it with an object-oriented database, in a document DB, we think of documents and not objects of the application layer, right? So we think of, hey, these are what are contained as documents. Objects have, why do we say it's not objects? Because in a typical object-oriented programming, object have methods and predefined schema and inheritance hierarchies. These are not present in a document database. So relationship between documents is de-emphasized, right? Whereas in object-oriented programming, objects means something specific, right? So they have to have objects, data, the attributes, they all have methods, they also have inherent hierarchies connecting one object to another. And finally, comparing object document database with XML database. XML database is a subclass of document database that is optimized to work with XML documents. All right. So you can also think of, because XML database is essentially XML file. So let's summarize what we have learned in this module. We started by reviewing the different types of NoSQL databases, and in this module we have dug deep into document database, right? So we've sort of seen the evolution of it, right from object-oriented database, which is all of it sort of helping to solve the object relational impedance mismatch between the data model and the application layer. Then you have the XML database. So we looked at XML enabled database and native XML database, which is essentially XML files, and then looked at document databases and the advantages and disadvantages of it. We also looked at how do we compare document database with the rest of the other databases we have looked at. So I will see you in the next video. Thank you.